So welcome to lesson 12.2. In this lesson, we're going to take graphing quadratics a little further and learn some more details about parabolas. All right, so what point is located at the vertex? The vertex is the lowest or highest point, and in this case, it is -2, -7. We're going to draw the axis of symmetry, which always is a vertical line going through the vertex. That looks like that. What is the y-intercept? The y-intercept is right there at 0, -4, where it crosses the y-axis. What are the two x-intercepts? Okay, now the two x-intercepts, please do that. The two x-intercepts are 1, 0 and -5, 0. And the x-intercepts have a name. They're called the roots, okay, of a quadratic function. So whenever we say we're going to find the roots, we're going to be actually finding the x-intercepts. So where on the graph of a quadratic function does y equal 0? Well, y equals 0 at 2, 0 and -2, 0. Those are the x-intercepts. Well, we also say where on the graph of a quadratic function does y equal 0? At the roots. All right. So we're going to use, this is called set notation right there. And so find the roots. So now if I say find the x-intercepts, you would write them as points, right? 3, 0 and -7, 0. But when I say find the roots, we're going to use set notation. There's typically, normally, two roots, but not always. And in either order, you're going to write the x coordinates of those roots, okay, of those intercepts. Okay, so the x-intercepts, the non-zero part, is called the roots. So we're going to find the roots of this one, right? The roots. This is a set notation. These are called braces, by the way. And they're at 4, 0 and -2, 0. So the roots are 4 and -2. And notice, by the way, this is the quadratic function f of x equals x squared minus 2x minus 8, that you can see the y-intercept of 0, -8 there. Okay. And because this is a positive there, the u is facing up. We call this a facing up u. All right, so those, typically they have two, but not always. So what's the root of the one we're looking at? Well, the root of the one we're looking at is 0, right? The x-intercept, there's only one, is 0, 0. And so the root here is 0, okay? For this one, this has no roots because the roots are where it crosses the x-axis. And since that never will cross the x-axis because it dips down to this lowest point and then goes back up, that has no root. So you can have one root. So let me make sure we all understand. If I have that, what's the root? Right, the root there is 7. So you'd say x equals 7. When it's only one of them, you don't have to put it in braces. Okay. All right, so the axis of symmetry is located at -b over 2a. So let's see that. All right, so we have a quadratic function here, f of x equals x squared plus 6x plus 5. Right, we know the y-intercept is there, 0, 5. We also know where the axis of symmetry is. It's located at x equals -b, right? These are in ax squared plus bx plus c. So it's at -b, -6 divided by 2a. A here is 1. So -6 divided by 2 is -3. So the axis of symmetry is going to be through the point, or it's going to be through x equals -3, or let me say that better. It has the equation x is always -3. That's the equation of a vertical line, right? That's what the equation of a vertical line looks like. And on that vertical line, the x-coordinate is -3. Let's do another one. All right, so in this one, it's still negative b over 2a. All right, once again, there's the y-intercept 0, 12. The axis of symmetry is located at -12 divided by, there's 2 times -3. -12 divided by -6. It's at x equals 2. It's a vertical line in which every x-coordinate is 2. All right, same thing here. So it's negative b all over 2a. Now, this is ax squared, but plus c. There's no bx, right? So b is missing. Why is b missing? Because it's 0. And this is 0 divided by 2, even if it's -0, is 0. So this is the axis of symmetry is a vertical line where x equals 0. Well, where does x equal 0? The y-axis. This is the axis of symmetry is the y-axis. Okay, so let's see that now. All right, so now to find the vertex, right, we need the other part, right? We know that we just learned the x-coordinate. That's what that x is, the x-coordinate. Now we're going to find the y-coordinate. All right, so let's do this. So find the location of the vertex. Okay, so we start with x equals negative b over 2a, which is -6 over 2, x equals -3. So what is the y-coordinate? It's y equals, x is -3 squared plus 6 times -3 plus 5 equals 9 plus -18, plus -18 plus 5. 9 plus -18, -9, -9 plus 5 is -4. So the vertex is at -3, -4. Okay, so let's see that. Let's practice that. So x is at negative b over 2a, -12 over 2 times -3, -12 divided by -6 equals +2. So y will be at -3 times 2 squared plus 12 times 2 plus 12. 2 squared is 4, right? Order of operations, exponents first. 4 times -3, -12. Well, that's very nice because these two will cancel out. And y will be plus 24. And so y equals 24. And so the vertex for this one is at 2, 24. Thank goodness we don't have to graph that one. For this one, these are the same ones we did last time, right? X is negative b over 2a, or -0 over 2, or 0. So f of x, or not f of x, y, we're changing that to y because we're trying to find the y coordinate. 0 squared minus 8. Y equals -8, so the vertex is at 0, -8. Yeah, the vertex for these, when b is equal to 0, right, when there's no bx in the middle there's no x term in the middle, what that means is the vertex is on the y-axis and it's symmetrical along the y-axis. Okay, so let's put this all together. So I've already graphed it, but let's see what we can do. X equals, the x-coordinate of the vertex is negative b over 2a. So b here is -2, so it's the opposite of -2 over 2 times 1, which is 2 over 2 equals 1. So the x-coordinate of the vertex is 1, and that's what the graph shows. To find the y-coordinate, we do 1 squared minus 2 times 1 minus 8. 1 minus 2 minus 8. Order of operations, 1 minus 2 is -1. -1 minus 8, -9. So it'd be a 1, -9. That's where the vertex is. This is called the vertex. All right. Where is the y-intercept? Well, it better be at 0, -8. There it is. There's the y-intercept at 0, -8. Okay. Questions about that? And what are these points up here called? The x-intercepts? They're called the roots. Okay. Okay. So the axis of symmetry and the vertex are always in the middle of the two roots, halfway between them. And this can be very helpful. So let's see what this is. The function f of x equals x squared minus 2x minus 8 has roots at 4, 0, right there, and -2, 0. So this is going to be a U shape because we know that because there's an x squared here. We also know that the axis of symmetry has to be, whoops, it's not there, halfway between. So where's halfway between these two things? It's right there. That's halfway between. All right, so that is where our vertex is going to be. Right, there's the axis of symmetry, which is, right, starts with x equals 1. Why is it important to know that? Think about this. Are you going to you're going to try to memorize x equals negative b over 2a. But what if you forget, right? Well, you have another way to figure out where it is. It's always halfway between the roots. So, right, let's just show that. So it's the opposite of negative 2 over 2 times 1, which is 1. X is at 1. All right, now you still have to put it in there to find y. 1 squared minus 2 times 1 minus 8. So 1 minus 2 minus 8, 1 minus 2, negative 1. This is the one we just did, isn't it? Negative 9. So 1, negative 9 is right there. We also know other information just by looking at this. What other information do we know? We know that there is a y-intercept right there at 0, negative 8. So let's plot that. I want to use a different color. So there's the y-intercept. We also know there's a symmetrical point, right, on the other side of the y-axis right there. Okay, so what does this all say? It says find the vertex. We did that. We found the y-intercept. We found another symmetrical point. And now we know, right, we know this is a U-shape facing up because there's a positive number there. So it's a U-shape facing up. Now, this isn't perfect, but we have a pretty good idea of what this has to look like from the two roots, the vertex, and the fact that we know it's symmetrical. And that's really what you're going to do in homework. Use your clues to draw pictures of these quadratic functions, these parabolas. All right, so let's try another one. So the function f of x equals negative x squared plus 4x minus 3 has roots at 1, 0. So we're going to do a little sketch, right? We're going to do it by hand. And here's our x-axis and our y-axis. And it has roots at 1, 0 and 3, 0. Well, I can't make it easier than that, right? So then we know that's where the U shape crosses the x-axis. We also know that the vertex is somewhere along x equals 2, right? Halfway between. Now, I did that with the roots, but you also could have used x equals negative b over 2a, right? B here is 4, so it's negative 4 over 2 times negative 1. Negative 4 over negative 2 equals 2. But it definitely was easier just to realize it's right down the middle of the two roots. Now, sometimes it comes out at like 3.5, you know, or something like that, and then it's not as easy. But anyway. All right, so now we're going to find the y coordinate. We just have to put 2 into that. So negative times 2 squared, it's going to be the opposite of 2 squared because we're going to have to do exponents first, plus 4 times 2 minus 3. So negative 4 plus 8 minus 3. Negative 4 plus 8 is 4. 4 minus 3 equals 1. So the vertex is at 2, 1. 2, 1. Right? It's up there, which should not surprise us. Why should it not surprise us? Because there's a negative in the front. So this is an upside down U. What else do we know? Oh, we know the y-intercept. It's 0, negative 3. 1, 2, 3. What else do we know? We know that there is a point over here, right? One more over that's symmetrical, all right? So we know, we have a pretty good idea that our parabola looks like that, right? So let's label the vertex. The vertex was 2, 1, all right? And there are the roots, right? The roots were 1, 0. Those are the roots. Or that's one of the roots. The other root is that's 3, 0, my fault. And 1, 0, and this is the vertex, okay? And that is the y-intercept. And that other point is just symmetrical to the y-intercept. All right, let's try another one. All right, so we're going to make a little sketch of this. Hopefully you're going to be neater than me. And the roots are at negative 5, 0. 1, 2, 3, 4, negative 5, 0, and negative 1, 0. Okay? Halfway down the middle of that is right there. That's at -3. So x equals -3. I'm not going to bother to do negative b over 2a. All right, but now I have to find y. So it's going to be -3 squared. Now this is the -3 is in the parentheses here, right? Because there was no negative there. That's why we had that outside the parentheses on the last one. Plus 6 times -3 plus 5. -3 squared is 9. 6 times -3, -18 plus 5. 9 plus -18, -9 plus 5 equals -4. So the vertex is at -3, -4. So 1, 2, 3, 4. That it's down there shouldn't surprise us because we know it's going up because there's a positive there. We also know the y-intercept. Plot it. Where's the y-intercept? 0, 5. So up here, 1, 2, 3, 4, 5. So this is a very skinny u. All right. Now, right, we're 1, 2, 3. So we need to go 1, 2, 3. This is 1, 2, 3 from that. So I'm going over 1, 2, 3 here and giving myself a symmetrical point over there. And so now I have 5 points. That's plenty to draw a nice little sketch of it. And we know it's a U, and Mr. Ben does not have a steady hand. He needs to improve. There he goes. Better. Not great. I missed. But that is a sketch of f of x equals x squared plus 6x plus 5. Okay, so let's... Now, this one says it has only one root. That means it goes to the x-axis and touches it and then goes away. And we know it faces up because that's a positive one there, or it's positive. So the vertex, so let's think about this. So we have, right, our x and y axis, and we know the y-intercept is 0, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, okay? And we know it has only one root. The vertex, all right, let's see. All right, so x is at -b over 2a. So I'm going to need -b over 2a this time. So the opposite of -6, because b is -6, over 2 times 1. The opposite of -6 is 6, 6, 2. X is at 3. All right, so the axis of symmetry, let's be a little more, keep our scale. 1, 2, 3. So the axis of symmetry is going to be there. Okay. And we know, so the vertex is going to be at 3 something. So I'm going to put 3 in the function. 3 squared minus 6 times 3 plus 9. 3 squared is 9 minus 18 plus 9. Oh my goodness. 9 minus 18, -9. -9 plus 9 is 0. So it's at 3, 0. That's the vertex. That's the lowest point, right? So now we know it's going to dip down to 3, 0, right? And we also know we have a symmetrical point, 1, 2, 3, 1, 2, 3 up here. So we know this comes down, sloppy. This comes down here in a U shape, not a V, even though that looked very V-shaped, Mr. Ben. And let's see if I can do better. All right. So you go down, just touch the x-axis. So the vertex and the root are both the same thing. The root here is 3, the vertex is 3, 0, the x-intercept is 3, 0. But there's a graph of this. All right, good luck on your homework.